Hello everyone. Our project title is AI Powered Nutrition Analyzer for Fitness Enthusiasts. The main purpose of this project is to have a healthy lifestyle and balanced diet. We are a team of 4. Myself Vasudha, the team lead, and my team members are
I'm Titiksha.
I'm Shailaja.
I'm Rosa. Initially, to start on with, we'll run our app.py. This app.py consists of the Flask code. When we run it, we'll receive a link. It may take some time, so we have already compiled it. We have received the link. Now we can run this link on any of the browser of our choice. For now, we are running it on the Chrome browser. This is the web page we have created. It has two buttons, the BMI calculator and the prediction button. The BMI calculator button is to calculate the BMI value, and the prediction button is to predict the nutrients and goodness in the food we consume. Now, we shall move on to the BMI calculator. When we click the BMI button, we will be directed to this page. I'll give you a gist of what BMI is. BMI means body mass index. It is a person's weight in kilograms divided by a square of height in meters. Now, moving to our project, it contains two slots in which we can enter the input, and by pressing the calculate button, it will show us our current body state. The output will be normal, overweight, underweight, or obese. The main thing is that you need to enter a valid height and weight. If not, it will show a warning. Secondly, moving to the prediction part. When you click the prediction button, it will predict the nutrients, vitamins, minerals, etc.
The selected image is predicted and the image is displayed, followed by the nutrients, fats, calories, etc. are listed below. The prediction process includes a few steps such as data collection, image pre-processing, model building, and Flask integration. Data collection process determine what information you want to collect. In our case, the data are apple, banana, bel puri, mango, burger, onion, pizza. The data is split into testing and training dataset. Training data is typically larger than testing data. This is because we want to feed the model with as much data as possible to find and learn meaningful patterns. Image pre-processing are a few steps taken to format the images before they are used by model training and interface. Data augmentation is a technique used to increase the input images with slight changes. By doing this, we can overcome the overfitting problem. Even without data augmentation, we could get good accuracy, but we could not get the correct prediction. For data augmentation, a few libraries are imported. They are TensorFlow and Keras. In Keras, a class called Image Data Generator is used. Few parameters are passed into the class, such as rescale, which is used to rescale the pixel, zoom range to zoom the image to 20%, and the horizontal flip, which means it mirrors an image in horizontal direction. After initializing the data, now we should pass the data. Since the data is in the folder, we should use assign a variable xtrain and call the train datagen. Now call the folders through the flow from directory function. Inside the parameters, give the path of the training folder, then the target size to convert the images to a particular size, then class mode to find the number of classes present in the folder. Batch size is 100 because the images are splitted into batches of 100 images. The same procedure is followed to X-test.
Next, we are going to build a CNN model. CNN is a kind of network architecture which follows a deep learning algorithm. In our project, we are going to use CNN for image recognition purpose. For that, first we are going to import all the required libraries. After that, we are going to initialize our model using sequential method. Now we are going to add CNN layers. There are totally 4 layers in CNN. They are convolution layer, pooling layer, flattened layer, and fully connected layer or dense layer. The convolution layer and pooling layer are used to extract information and reduce the dimension of the output. The output of the pooling layer will be in the form of matrices. The flattened layer will convert those matrices into output vectors. The dense layer follows ANN approach. The main advantage of dense layer is it is deeply connected with the preceding layer. So it makes training faster. After that, we will compile our model. Now we are going to train our model using fit generator method. This may take few minutes based on the number of epochs you give to train the model. Epochs is nothing but the number of times you would like to train the machine with given entire data set. The more number of epochs you give, the model will be more accurate and the time taken will also be more. Next, we are going to tune our model. This step is often considered as an optional step. So if you feel your trained model is underfitted and its prediction accuracy is less, then you can go for this tuning step. This will increase your accuracy and the image will be predicted more accurately. Now we are going to save our model. Here I am saving it as nutrition.h5. This is further used for testing and prediction purpose.
Datas are of two types, structured and unstructured datas. We use deep learning techniques to process image as it is an unstructured data. CNN comes under deep learning technique. To use Flask application, environment to be set up and few libraries like TensorFlow, Keras, Pillow to be installed. Flask is a web framework in Python. It is a collection of libraries and modules enables particular web application. To use Flask, structure is to be followed. Two folders to be created, static and template. Static is a main folder for subfolders like CSS, which contains .cs extension files, then JS that contains JS files, and then folder for images. Template folder is the folder for HTML pages. Now initialize the Flask to use it. Using load model, .h5 file is loaded. To use this, TensorFlow must be installed. When this application runs, first home page will be displayed. Using action parameter, web pages are redirected. Request.files stores image in a folder locally that is uploaded in the web page. The saved image is loaded again using load image. This image is converted into 3D arrays for fast operation. Expand dimension expands the shape of an input array. Here are the nutrients defined inside the function. These values are returned back to the prediction page and are displayed below. Thank you.